In today's Retro Tech Repair, we'll be using some unusual techniques to repair an unusual problem on this Japanese Astro Wars. So today's video requires a little explanation. One of the first things that I repaired on the channel back in 2018 was a Grandstand Astro Wars, and that machine had what I have now discovered to be a very common fault, and a lot of similar games that I have repaired since then have had the similar fault. So I discovered through the comments on that video that some users were experiencing a different problem, that of faint sound and faint or no display, and that's what today's video is about. I intentionally bought multiple Astro Wars with that problem and set about diagnosing it. The video shows me trying to diagnose the fault, largely by trial and error. So today's video is a lot longer than my usual videos, shot over several months, and more in the style of one of my favourite YouTubers, My Mate Vince. Now, My Mate Vince fairly recently repaired an Astro Wars on his channel with a similar fault, but it needed a different fix, so hopefully my video is still useful. In case you are in a hurry, I will put up the point in the video where I start to repair the final machine using the information I learned, and you can fast forward straight to that. But if exploding parts, Japanese import games or high voltage DC are your thing, I hope that you will join me on the journey that got us there. So here is our eBay listing, rare Astro Wars Japan version, Epoch Spares or Repair 1980s box with instructions. I paid £50 including postage, quite a lot of money. We'll read through the description. Rare Astro Wars Japan version in original box with instructions, sold as not working. It was working perfectly but has been stored for a couple of years. I couldn't find any batteries to test it with yesterday, so I plugged in a mains charger and it worked faintly. Worked faintly, that's interesting, but then died and I could smell a faint burning. Not a good sign. I then bought some batteries to test it with, maybe a bit too late, but as soon as I put them in, there was a little smoke coming out of the unit. Oh dear, I have clearly burnt something out by using the wrong charger. I am an idiot who shouldn't be allowed nice things. The internal photos are taken after the accident. No major signs of damage, still a rare item, hopefully someone can repair it. Well, let's hope that I am that someone. Before I do that though, we're going to take a look at what we have here. So at this point I decided to use real-time Google Translate, and here are some of the things that I learned from the box. Astro Wars could be an up-rat-style space game that redefines the universe, or an upright space game to re-examine the universe. In the game center, game content to follow, large multicolored display of Akagatari Taki Green, electro sound and melody full of presence. Le convenience that you can play according to your ability, re-examining outer space pre-light type, same joystick control as game center. So in fairness to Google Translate, if I had had a steadier hand, I might have had a better understanding of what the box said. But for now, let's go to something that's a little bit easier to interpret. Here it is, nonetheless, our Astro Wars, and you see it's quite different visually. It actually has a portrayal of the aliens. The normal Astro Wars box doesn't have that, or at least the European or UK market Astro Wars does not have this kind of graphical representation of what the attacking alien looks like. So it's interesting to see how somebody interpreted that. I don't know how you interpret that in your own head, but I guess that's what the artist believed that the invaders looked like on this Astro Wars. On the top we have the spaceships, perhaps that's your spaceship, and on the back, fairly conventional rundown of the various levels, obviously with the Japanese language text on there. On the side, some more Japanese language text, and then again here, some of the features explained. Alright, so let's see what's inside of here. There is a price tag. If I interpret this correctly as 8,800 yen, then even in today's money, 8,800 yen is 82 US dollars or 66.34 pounds sterling. Think how much that would have been back when this was new in maybe 1982, something like that. 1980, 1982, I'm not sure when this exactly would have come out. That really was an awful lot of money back then. So if we continue looking inside, the original packaging, and of course the game itself, which apparently smells of smoke a little. Let's set that aside a second, and we'll take a look at our instructions here. got Astro Wars instructions. I'm going to take another look with Google Translate and see if I can decipher what those words are. Oh well, perhaps that's best unsaid. Just take a slow look through these instructions. Obviously they don't mean very much to me. Looks like it features our AC adapter again, visually as well, for the poor seller. I have my suspicions that might not have been all of their fault. And we'll take a look at the back of the instructions too. All in pretty nice conditions, a little bit of yellow end, but they're not too fragile. And of course there's some marks on the box too, but pretty nice condition. Also we have here the original warranty card, again in nice condition and not filled out. So now let's take a look at the game itself. There's a little bit of surface, few surface scratches, but actually very light. Sometimes I will try and polish those. I don't know if I'll even do that for this one because it's in such nice condition. There's a mark on the bottom, another label, not quite sure what that says. And in English, 1981 Epoch Co-Limited. So 1981 was when you were looking to spend about $67 US on this. I do see some marking on the screw heads, but again we knew that this had been taken apart. Let's take a look at the battery compartment. The battery compartment's nice and clean. The door's a little bit loose. You do get that sometimes with these. So I think at this point we're going to pause our investigation into the Japanese Astro Wars and take a look at the two UK units that I'd repaired earlier in the year. It was these UK units that I'd used to diagnose the cause of the problem that it turns out our Japanese Astro Wars has. Today we're going to be looking again at a Grandstand Astro Wars, or actually two Grandstand Astro Wars. The first one is in fairly nice cosmetic condition. I've got this partly disassembled, I do have the rest of the parts, but it doesn't work and it's a different fault to the one that we've seen previously. This one works perfectly but is in poor cosmetic condition. So what I'm going to do is I'm going to try and fault find this one, and then if I need to take some measurements and see what's going on with it, I can take a look at maybe this one as an example and see if I need to take a voltage measurement or resistance measurement or something like that. I can take it from the good one and see if the bad one is the same. And I'm hoping it's a different fault to the other faults that we have seen. Let's get the power switch here from my box of parts where I disassembled it. If we just put that in place, hopefully you can hear that. If I drop the lights there, you can see there's no display. So I'm going to take you through my thought processes now as I look and diagnose this as best I can. Taking a look at the board, I think the first thing that I tend to do is I'll take a look at the printed circuit assembly, and I'll be looking for any burnt tracks, split tracks, anything where there may be acid damage on the board, corrosion, something like that, dry solder joints, solder joints that have cracks. When I look at that, this is pretty clean. Sometimes also I'll look at it through a magnifying glass. I have an illuminated magnifier that I use sometimes to look at things. But in this case, I really don't see anything on there. And I don't see any battery acid or battery alkali probably damage in the battery compartment either. So the battery compartment here is pretty clean and the connections to the battery are present. What I've been doing in some of my others is I start to trace the voltage around the board, but more recently I've focused on the components themselves, and there's no rhyme or reason for doing that. That's just the approach that I've taken, and probably each is equally good. But in this case I'm going to look at the components. So I'm going to start by checking all of the transistors and diodes. So maybe we'll do diodes first because that's pretty simple to do too. So we'll switch the meter onto diode test, and we're going to start going across with the meter on the meter probes each of the diodes that we see, and we expect to see about 0.8, 0.7 of a voltage drop across the diode in one direction, and then in the other direction we really shouldn't see anything. That's exactly right. So if we're going with the way the diode would ordinarily turn on, then we see about 0.7 or 0.8 of a volt. So that's okay on that one. We're going to do the same on this one.
Maybe I got that the wrong way around. I think I did. 0.8 of a volt. And on this one, 0.8 of a volt. And there are 1, 2, 3. I think there's one just tucked away in here. So let's take a look at that one too. That's a little bit less. It could have some components in parallel with it. Let's just turn it around, check it the other way. Of course, the real best way to check these is to take them out of circuit. That shows some resistance the other way. So definitely that diode is potentially suspect. We really need to lift it out of the board to test it more thoroughly. Now, a transistor is almost like a diode back-to-back. So a diode often is a PN junction, a positive negative junction if you like. It's the doping they apply in the silicon. And a transistor, or at least a bipolar transistor, is either a PNP or an NPN. So it's almost like two diodes back-to-back, and that's exactly how you would test them. And I looked at the part number for each of these transistors, and they are NPN transistors. And what I should be able to do then is, and let's just prop this up so I can see, and hopefully you can see too. I'm going to put one probe on the base, which is the P in the NPN. We're still on diode test here. Yeah, the positive probe on that. And I should see that same 0.7 or 0.8 of a voltage drop to each of the other two pins, the emitter and the collector. So let's try it here. 0.7 to that one, or 0.8, and to that one the same. So I think that is a good transistor. We'll do the same on this one. 0.8. I think I was not quite touching there. 0.8. So I'm saying that's a good transistor. I'm going to do the same on this one here. Collector and emitter. So that's looking good too. So the only thing that's looking maybe a little bit suspect right now is this diode down here, where we see 0.14 of a volt drop in one direction and 0.5 of a volt drop in the other direction. So maybe we'll take that out and take a look at it in a little bit more detail.
So as I often do when I'm trying to effect these repairs, I decided to remove the printed circuit assembly from the plastics. It just makes it a little bit easier to work around whilst I'm trying to repair the printed circuit board, and also it saves me accidentally melting some of the plastic enclosure.
And we're going to take a look at our diode. It's actually tucked away behind here. You can see now behind the plastics, hopefully. Our diode, I could do something to point with, it's hard to make out, is right here, next to that fairly meaty cap. I think it's this pin here, and that pin there. So I think it's these. Interesting, there's something that was really hot on that board. Oh, it's this power transistor. That power transistor is really warm, dissipating a lot of heat. So this has to be suspect too. This has just caused us so many problems in some of the other boards, and it's so hot there. Interesting, I didn't expect that to be the diagnostic that I would use. So it's between this diode and this transistor, even though this transistor tested good. Because I've had so much trouble with these, I might try that first, or maybe I'll try the diode. Let's stick to the plan. Let's try this diode. What I'm going to do is I'm just going to lift one leg of it and see if it still behaves the same way. That looks good. 0.8 in one direction, nothing in the other. I'm going to say that this diode actually is good, and we were probably just misled a little bit by the surrounding components. So we just slide that one back in now, hopefully, and then we'll solder it back up and we'll move on to try this transistor.
One of my favourite YouTubers is my mate Vince, and fairly recently he repaired an Astro Wars on his channel and came to a very similar conclusion to the one that I'm about to come to. Now I know that Vince is a subscriber to my channel, and like all of my subscribers, I'm very excited that he's following my content. But we'll see as we go forward that my particular Astro Wars has a few surprises for us yet to come.
We'll just double check that again. Positive on the base. Diode check. 0.8 of a volt. 0.7 of a volt. I'm also going to check it the other way round. So we shouldn't see any. Oh no, that's good. We shouldn't see any the other way around, and there we are. That is interesting. So even with the positive on the collector, remember this is an NPN transistor, so the collector should be negative, the N. Even with us having the positive probe on the negative layer of the transistor, the bipolar layer of the transistor, we still see that 0.8. So in fact the behavior this way around, as it should be, 0.8, and this way around, the other way around, also 0.8. So it's almost like this is behaving now like a resistor and not as a diode, because it's letting current flow in both directions, from the base, from the collector to the base, and from the base to the collector. So I think this is actually our problem part again. You know, every single one of these that I do, so far at least, has had this transistor faulty. It's nicely lined up there, so we'll take it out of the board again and we'll take a look at it when it's out of circuit. Still a bit hot, but it's hot and it's on the bench. And we should have 0.8 of a drop, 0.7 of a drop really, 0.7 or 0.8 to the emitter, and then to the collector. And then when we switch those around, we should not see anything in the other direction. So we don't see anything there, and we don't see anything there. So this is starting to look like perhaps it is a good part, which is behaviour quite different to how we had it in the board. So I'm glad we didn't cut it off. What I'm going to do, I'm going to double check that now. I have a little device that I bought on Amazon. You can buy them on eBay. They're very affordable, and they're quite ingenious little things. You just pop it in there and it will tell me what this part is, or what it thinks this part is. I press this button and there it is. It's an NPN transistor with a current, an HFE, a gain of 107, and the base, emitter and collector. So this is not a bad part by the looks of it. I have some of these, so I'm going to check the measurements here against a known good one and we'll see if they're the same. HFE of around 100, UF of around 600. So let's take that out and we'll pop a good transistor in, known good transistor, and we'll test that the same way. Ah, interesting. The HFE there is about 300, although the UF is the same. So let's try a different, because I have more than one known good one, a different one. It's from a different batch. I think it's from the same supplier, but I bought them at a different time. So let's see what the value of HFE is on this. Around 300 again. So this is starting to look suspect, despite the fact that when we tested it with a multimeter, it tested good. So what I'm going to do now is I'm going to try and look at the data sheet for a D882 and see what the HFE should be. Okay, so I looked at the data sheet for a D882 transistor. I don't know if you can make that out or not, but what's interesting is that the HFE is between 100 and 300, so both are in spec, although one's right at 1 end of it and one's right at the other. I'm tempted to just replace that anyway since I have it out and because I've had so many problems with it.
So at this point I decided I was going to take a look at the working Astro Wars. I measured the temperature, or at least I felt the temperature of the suspect transistor with my finger, and then I drew the wrong conclusion.
So I'm going to go with our theory that that transistor is bad, even though it tests kind of okay with a multimeter. It's strange. I think maybe it is, what's happening is it's warming up, and then as it warms up, it's starting to fail, so that when I tested it in the board when it was warm the first time, it looked like it had failed. And then when I took it out of the board and tested it on the bench, once it had a chance to cool down, tested it in our little tester here, once it had had a chance to cool down, then it performed okay.
As we discover later, this was complete nonsense.
Now is take a good transistor and we're going to put it in there, and hopefully that will solve our problem. Alright, so I think that's soldered in. I genuinely do not know how this is going to perform now when we connect it up. Interesting. Doesn't seem to want to start up at all now. I wonder if this transistor is getting... Ow, that is still getting hot. Okay. So, I think there's something going on with this. I don't know what it is. That part's still getting hot. So maybe the one we took out is still good. I do have it somewhere. So we won't discard it. And I'm not going to trim the legs off this one because we might end up reusing it.
So I spent a little time tracing the various tracks that connect to the transistor around the Astro Wars. And it seemed to connect to the small transformer and then inevitably to an electrolytic capacitor. So it's quite common when I repair these games that somebody says in the comments, you should have recapped it. So I thought, well, why not? What have I got to lose?
I have a selection kit of caps here. And I'm going to pick the 10 microfarad. It's actually, I have a 25 volt and a 50 volt. So I can pick the 25 volt because 25 is still more than 16. And it's 10 microfarads to 10 microfarads. And as I say, you know, it probably isn't faulty, but given that they are so prone to failure, why not just replace it? Right, and I expect that the performance of the game will be just the same as it was before, i.e. we won't get a display. And indeed it is. Interesting. We're not getting the... Whoa! Pretty sure now this is a failed D882 is a good one. When we put it in, we tested it on this tester here. Still a bit hot. We tested it on this tester here, so let's test it again. Let's see what the tester says. Now it's smoked. Oh. That's strange, isn't it? It seems to have triggered some kind of self-test. Dead short between those two pins, which of course should never be, and almost a dead short between these two as well. So totally toast.
So by this stage you can tell that I've resorted to trying to draw a circuit diagram. Now I'm sure there's lots of inaccuracies in that, so I wouldn't rely too heavily on it, but what you might notice is there's a diode shown in the bottom right hand corner with a question mark next to it. That might just be relevant later on. And what I'm doing is I'm taking voltage measurements around the transistor, and what I see is that the voltage that's supplied to, I think that's the voltage on the base of our transistor here. The voltage on the base on the working version is negative 1.5 volts, but on the non-working version is 5 volts. So this voltage here is minus 1.5 on the working version, but only 5 volts on the non-working version. That comes in via this transistor here. This is the smaller transistor. On the working version, that has a base voltage of minus 3 volts, which is derived from a minus 9 volt line through a Zener. And this has, when I look at the non-working version, I see that this voltage here is 5 volts, and that this voltage, this line voltage here, is 5 volts also. So what I'm not quite sure is, has this transistor here failed, which is bringing all these voltages, if this is shorted, maybe bringing all the voltages off this 6 volt and just bringing everything down? Or is there something on this 9 volt line elsewhere which is causing it to be at about 5 volts, which is where it is right now? If I look at the voltages on this board, on the pin of my, now what is that? That is the base of my D882 there, I get 0.5 volts, whereas on the base of my D882 here, I get minus 1.4. And that does come from this transistor here on the other side of the board. That's this little chap here, which is SO3. So I think I'm going to take out SO3 and see if I can test it and get some voltage measurements around there. Please ignore this diagram. I know it's messy. I got some of the symbols wrong. Everything's wrong with that diagram, but it's just a work in progress right now. So I have the part out of the board now. It's a C945. I'm just going to pop it into our little component tester here and test it, and I'm sure it's going to be fine because it tested fine before, and indeed it is. Everything's just as we expect it to be. So I'm now going to take some more voltage measurements around here and see if any of the voltage levels have changed now that that part's out. So I'm still looking around at voltages here. This minus 3 volts, which is what we have on the working board here, on our non-working board is almost 6 volts. So that, I think, comes through SO9. SO9 comes from the 9 volt line, or minus 9 volt line. The minus 9 volt line on our board here, if I get the right one, that one. It's minus 9 volts on our board here, but on this board, it's at 1.3. So it was at 5, it's now at 1.3. Minus 9 there, 1.3 on the same spot there. So obviously taking the transistor out has had an effect, but still there is a problem that this minus 9 volt line is not minus 9 volts on our problem board here. So that's the next thing that I'm going to go looking for. We were looking at voltages around this transistor, and we saw that we had 5 volts on that pin where we'd have expected it to be from the working one about minus 1.5. There is a pull-up. I found a pull-up on this line, pull-up resistor across here, which I think is the thing that's pulling it up to 5 volts. I think it's the absence of this negative 9 volt line which is the issue, and I'm really struggling to find what that negative 9 volt line is fed from, how that negative 9 volts is generated, and that's my focus right now. This is our working board, so we do have our minus 9 volts here. If I just bring this into shot, we can hopefully see that we have minus 9 volts on that pin. When I look at the other pins, I feel like they are all, if you like, taking off that 9 volt supply. So there's some capacitors here, there's the resistor matrix here, there's a Zener diode here which is dropping, I think, to minus 3 volts to drive our base on one of the switching transistors. We have a couple of resistors and some other transistors here. I'm not quite sure what they're doing, but the tracks at this side are very thin, so I don't think they are supplying
current to this line. So as we come around here, we hop over here and we get into another resistor array, and we're on the supply voltages of the IC. So I think the only place that our 9 volts can be coming in is right here. I'm thinking that either this diode that's on the back face here, I think that's maybe SO7, I'll check as we turn it over, could be the problem, and if it's not that, then it's probably this transformer here. So those are the two areas where I'm going to concentrate now. Hello! Well, I just wanted to give you a quick update. I switched out these diodes. So I took the what number is it now? I took the SO7 out of this board, that's the non-functioning board, and I put it into the functioning board, and I took the SO7 from the functioning board and put it in the non-functioning board. So basically I switched the SO7s from one board to the next, and unfortunately the problem did not move with the diode. So replacing that diode didn't help. That diode isn't at fault. So at this point, out of desperation, I decided to recap the board. This didn't work either, and so now we'll move on to our next misdiagnosis. Now I'm left with changing out this P switch. Is the one thing that I think might be remaining. I haven't tried and could be the potential cause. I'm thinking it's some kind of transformer, but what's interesting is this is from a salvage board, so I don't know if this could have failed also. So I soldered in the transformer from the salvage game and it didn't work. So I unsoldered that and soldered in the transformer from the working game. Let's rejoin the video for the big switch on. So I've taken the part out of the good board and put it in the bad board. So this really is the moment of truth, and you will see at the same time as I do whether this has fixed the problem. So here goes. It has not. So I'm back again, and for the life of me, I think my mind must be playing tricks. So for a long time, I have been chasing why we didn't have 9 volts on the 9 volt line, or minus 9 volts on the minus 9 volt line. And I have now, this is the bad board still hooked up, still behaving as it was. We get the sound, a high current drain from the power supply. So obviously it's drawing more current than it should. And when I look before, I was sure, or fairly sure, that we didn't see 9 volts on the 9 volt line, or negative 9 volts on the negative 9 volt line. Which seems strange to me, because I thought that why would the microprocessor start up, because it needs a minus 10 volt supply. Why would the microprocessor start up if we didn't have the minus 9 volts? So I went back and I checked it again, and we do have that minus 9 volts. So I'm just going to very briefly do this. Just going on the negative here, and the minus 9 volt line. Tricky job to do with one hand, and then we're briefly going to switch the power supply on. It's minus 8, minus 9 volts. Just as we expect. We have no display as before. So I'm a little bit bamboozled how we got here, if you can be a little bit bamboozled, or whether you have to be totally bamboozled. I'm not sure, but I'm going to go carry on testing, but I just wanted to come in and show you that. Okay, so I'm back, and I have the two boards side by side again, so I can take some measurements. At the moment I only have the good board powered up. Just going to take some voltage measurements on that, and then we're going to look again at this one. When I come around here and I get to the biasing of this smaller transistor here, or the switching of this smaller transistor, I see a -3 on the base. So I should have a -3 on the base, and that -3 I think comes through here from the negative 9 volt line via a Zener diode, dropping it to -3. And in fact I even showed that on my diagram that I drew I think yesterday, and I say this diagram is very questionable. Lots of it's probably wrong, but I did have this -3 from a negative 9 volt line via this Zener diode SO9. And that's a good contact. So -3 volts there. No. Okay, so we didn't see it. It gets onto this line via here, which is SO9. And I thought we'd given SO9 a bit of attention before, but maybe we haven't. Solder joints don't look like my own. So I'm going to try and take SO9 out. Now, these things are kind of strangely labelled, but we're going to take it out. We'll pop it in the tester and see if it works in the tester. And then if not, we might just try replacing it with what I am assuming to be a 3-volt Zener, but I don't know. That's an assumption. So let's take SO9 out and take a look at it in the tester. Oh, well, it knows it's a diode for sure, but whether it's working in that Zener function, it's really hard for me to say. So I did take a look at the part. You're not really going to be able to see it on my hand. It's very small. It's an assumption that it's a 3-volt Zener because there's 3 volts in that position on this board. What I'm going to do is take the one from the good board, pop it into the bad board and see if the problem moves or the problem improves when that Zener is replaced. One more time. No, just the same. Just the same, just an increasing current consumption and no display. So I guess we rule out SO9. We'll solder SO9 back into, this is the one that came from the bad board. If we carry on at this rate, then eventually we're just going to end up with all the parts swapped over and still nothing working. And again, we have our minus 10 volt supply. Really quickly there. But we do not have, we have a 0.5 volts here where we should have minus 1.5. So I'm going to start lifting other parts off of that track now. Okay, so the first thing we lifted was this this resistor R09, and when I lift R09 and power it up, I have my 6 volt supply, but I don't have my minus 10 volt supply, and there's nothing anywhere else. So obviously that resistor is part of the startup. It's required there to originally bias this or something. I'm going to take a resistance measurement on that, make sure it's okay. I doubt very much it's changed, but we'll test it anyway. And then we'll solder it back in the board and we'll move on to the next part. Okay, so CO8. CO8, one leg lifted. And we'll get ready to measure the voltages as we power up here. I'm going to start with the negative 10, see if we have the negative 10, and then we're going to go to see if we see the value here and see if that's negative 3. So let's start. And we have to be quick because we don't want to overheat that transistor. Do we have negative 10? We have our negative 10. What value do we have here? Close to 0. And we're drawing 2 amps. So we need to turn that off before that cap, before this transistor blows, which is getting mighty hot, and we'll move on to our next part. Still working on it. Next thing I disconnected was CO8. CO8 was interesting. When I disconnected CO8, the voltage and current just ran away completely. So I had to switch it off very quickly. In fact, I thought I'd damaged the transistor D882 again, but I hadn't. So CO8's clearly relevant, but again, I don't know if it's the cause of this failure. So CO8, something to think about. CO7, you seem to be able to take that one out of circuit and not make any difference at all. But CO8 made a huge difference, so something to think about. But we're going to carry on seeing if there's something else there, changing the voltage level on that. I took out R06, I measured it, it's the correct value, 330 ohms, and I resoldered it back in flush with the board, and still, unfortunately, the game is behaving just as it did before. So welcome back. Quite a lot has happened while you were away. The first thing that happened, a little while ago actually, the joystick board fell off, just fatigued on this ribbon cable, so I abandoned that, wasn't using it anyway. And then eventually the power board fell off. This was on the non-working Astro Wars. That fell off too. So what I had to do then was I had to solder a couple of wires directly onto the back of the board, which I've done, and then I'll solder that up if I ever get this one working, or when I get this one working, I'm going to solder that back up. And then what I got to do was look at the two boards again, and I'm still trying to chase why we don't have minus 3 volts on that pin there, and I disconnected all of the things that might be taking that -3 volts away, and I swap some parts around, which you've seen already. But on the working board, just in there are two Zener diodes, and they're numbered SO6 and S11. Now, I think this is actually a later edition of the board, because this version of the board, the non-working board, has the Epoch logo on. Epoch were the original kind of manufacturers of this board, and I think Epoch licensed it to Grandstand. So I think this is the earlier version of the board. It certainly has one Zener behind there, whereas this has two. Now, I'm not an electronics designer, but I've worked with electronics designers in the past, and generally when you up-rev a board, you're trying to reduce cost to take parts out. So the fact that there's added a part in on this board suggested to me that perhaps there was a reliability reason to add that in. Maybe this first version was unreliable, or there was some problem with it. So then I got to thinking, okay, well, you know what I'm going to do? I'm going to lift a leg on SO6, SO9. Oh yeah, SO6. I'm going to lift the leg on SO6, the part that's tucked away behind there, the one that there are two of on here. Because if it was a reliability issue, then perhaps this is the part that has failed and has become unreliable, this little Zener that's tucked away under there. And when I did that, and I hook up the power now to my new cables, and I power on the game, it still doesn't work. Well, of course it won't, because I've taken that Zener out. But it's not drawing that excessive current anymore. So I see the -10 that I had seen before, but now I get a -3 or 4 on that pin that I've been hoping to get before. So lifting that Zener out right there, the one there are two of on here but only one of on here, seemed to resolve that problem. Okay, I'm back. It's the next day, and just to give some kind of point of reference here, I'm probably on day 5 of this Astro Wars right now, and actually it was kind of close to giving up when I hit across this diode. I have the diode here. I've taken it out of the faulty Astro Wars, and what I'm going to do now is I'm just going to put it in this little component tester that I have here. I don't want to bend the legs back. In fact, it probably won't go. So I've just got this little thing that I made up with a couple of clips. I'm going to put one on each side, like so. And this is the one we removed from the faulty board. Pop it into the component tester, and it thinks it's a resistor. Okay, so obviously I'm a little bit stuck because I have this mystery diode that I took out of the board, which I really think is faulty, but unfortunately I have no mechanism of really confirming that or of telling what value it is. So the best that I'm left with really is to look at my collection of scrap boards, and this is a scrap board that I had from a it's like it's from a scramble. Okay, so this is from a scramble. It uses, if not the same, then a very similar, in fact the same microprocessor. So the layout is actually quite similar to our Astro Wars here. And then when I look at our transformer here, and I look at a line that goes very similar kind of path to the one that I'm tracing on our Astro Wars, and I see a diode off it, and this is that diode. Interestingly, it's called SO6 also, so from the same design house maybe. Obviously that's just, that number by the way is not related to the value of the part, it's just the number they gave it. The first one they used would have been 1, the next one 2, the next one 3, the next one 4, but there's our SO6. Now, there's also an SO11. Not quite sure what path that takes. It doesn't seem to be in parallel to our SO6, but you know, these two are our best bet of finding something that's the same, and you know, it's going to be, honestly, it's just going to be a gamble, and we'll have to stick it in the board and see what it does. But that's my best bet right now. So I'm going to pull these. I don't want to get them muddled up. We'll see if we can use them, see if they make a difference when we put them in our Astro Wars.
So after a little bit more investigation, I did determine that the two diodes are connected in series on the scramble board. And what I'm guessing are the two equivalent diodes are connected in series on the later version of the Astro Wars board. Now on the earlier Astro Wars board, there's only room for one diode. So what I did was I connected the two together, and then we're going to try and insert that combination of the two soldered together into the older version, the non-working Astro Wars board.
So I don't know if you're going to be able to see this or if the camera will focus, but I have the two diodes back to back. Now I'm just going to solder those two together, and hopefully we'll get a configuration which is quite similar to the one in our working Astro Wars. Here we have them now soldered together. And now we're going to solder them back to back into that board. They're still in the same configuration. I'll just put one lead in each of the holes. There are my two diodes soldered in there in place of where the one diode was, and we'll try it. Yes, excellent. So I don't know what those parts are and I don't know what those values are, but our scrap board that we bought on eBay as a job lot of scrap boards has really saved us there. You know, very happy with that. This has been like a 3-day journey, probably a 5-day journey. So I think what remains for me to do now is I'm going to just lay those down a little bit so they don't bump into this when I reassemble it. And then I'm going to solder on these connectors that we lost, and I'm going to reassemble it into the enclosure.
So the good news is that I did go on to characterize the parts that we stole from the scramble board, and I did come up with an alternative diode that I was able to buy new on eBay and use in the repair of our Japanese Astro Wars board. All that is to come in this video. But first of all, I want to take you back in time. For me, this was about 4 days. For you, it was probably about 40 minutes. But let's have a look where we were earlier in the video.
Definitely that diode is potentially suspect. We'd really need to lift it out of the board to test it more thoroughly.
Oh dear. So it looks like if I had gone with my first instincts, I'd have saved myself about 4 days of my own time and about 40 minutes of yours. But after we've reassembled the game, let's take a look and see if we can characterize the part that we took out so that we can buy a new one to repair future games. So this next section really needs to come with a warning. I am not an expert in these repairs. The information that comes out of this next few minutes could be complete nonsense. Please don't take it as advice. Please don't do this at home. What you are about to see is not safe. Just something that I did to try and understand and to try and find a part that I could use to repair my Astro Wars. While I'm at it, I should also apologise for the yellow appearance. I think the blue of the matte threw the white balance off on my camera. Or perhaps it was lighting. I don't know.
I have my little Zener test setup here. I have a bank of 9-volt batteries. From the 9-volt batteries, I go through a 10k resistor. In series with that 10k resistor, at the moment I've just got a conventional diode. And then across that diode, I am measuring the voltage drop across that. So we'll first of all just try with our conventional diode, put that in. This is forward biased at the moment, so there's no voltage drop across there. It's conducting just as you would expect to conduct. If I switch those around now on my battery and switch the polarity, so you can see it here, then I can see that now there's a potential between that of about 50 volts. So what's happened is this is no longer conducting, and because this is no longer conducting, there's a potential difference between those two. Now, what should happen with our Zener diode is that we should get a similar, it should conduct in one way, and then the other way, it should conduct at about the Zener voltage, which if we take a known Zener here, this is a 3.3 volt Zener, so let's try that. Just going to put that in circuit in place of our conventional diode here. And we see in one orientation, it has 3.2 volt voltage drop. So that's reverse biased now, but it has a 3.2 volt voltage drop. So once it gets to about 3.2 volts of reverse bias, it starts to conduct. So that's our 3.2 volt Zener. Actually, I think it's a 3.3. I don't know if I turn that down. 3.24. It's 3.3 volt Zener. And when it's reverse biased, it conducts at about the Zener voltage of 3.3 volts. Okay, so what we're going to do now is we're going to take our mystery part, the SO6 from our Astro Wars, and we're going to put it in the same configuration. So that's in the same configuration, and when we apply the voltage, we get the full 50 volt voltage drop. So this still is not conducting. If we switch it around, we can switch it around here. We see it is conducting, and we get about 0.6 volt voltage drop when it's forward bias. So in reverse bias, it's still not conducting at whatever this voltage is, 50 volts. So I've got quite the battery pack there. If I just very quickly measure the voltage across it, I have almost 90 volts, 0.7 of a volt voltage drop, so that's what we'd expect. And then as we switch the bias around, $89 volts again. So my guess is that either this is a Zener diode with a Zener breakdown voltage of greater than 90 volts or 89 volts, or it's just a conventional diode. Obviously by now the money that I've spent on this is far greater than the value of the part that I'm replacing. I could have probably bought another Astro Wars that worked for the amount I've spent on batteries, but what I'm curious to do is just understand what this voltage is, and so that if I need to replace the part in future on a different game, I can go ahead and buy what I need. So let's see what we have now. 116 volts. So I still don't think we've reached the Zener voltage of this diode here. Just checking I'm not getting any heating or anything unpleasant going on here. Like I say, really don't do this at home. 140 volts. Well, all I have left is this one now. So if this doesn't do it, then we're back to square one. $143. Wasn't the last one about 143? $141, $142. So maybe we're getting close. So what I'm going to do, I'm just going to measure the voltage directly across to see what voltage we get off the battery pack. So now off this battery pack, we're getting 169 volts. We're back again with our Zener test setup, and when I just check the voltage across this battery pack, I see I have 160 volts, roughly 159. This is my known value Zener, which will be in reverse bias. So I'm going to measure the voltage drop across that when I connect it up to this pack, and it should be in the order of about 3.3 volts. 3.7 volts, so that's our known value Zener. We're now going to take our mystery Zener, and we're going to put this across our battery pack. Okay, our battery pack is 160 volts. So if this Zener drops something less than that, then that might help identify what its value is. So we'll take our known 3.3 out of circuit, and we'll put our mystery Zener into circuit, and we'll connect up our meter again to measure the probes. We'll connect up our meter probes again to measure the voltage. And let's see. 140 volts again. And when I put another battery on, Try it one more time. 140, 143 volts.
So I refer to our mystery part as the Zener diode, or Zener diode if you prefer, quite a lot, but I'm still not totally convinced that in fact it is a Zener diode. It could have been a diode which has about 140 volts reverse breakdown voltage. Now I did check all of the working parts that I had, so I took the parts from the working Astro Wars and checked both of the diodes that were in series, and both of them were the same, or at least had similar characteristics, with a Zener voltage of around 140 volts. So now that I've shown our two Astro Wars working side by side, we can return to our Japanese unit, and in case you don't believe me, watch out for the Epoch logo on the front of the Japanese version. Oh, and I got a new watch. There we go. Okay, so I'll pop these aside, just pop everything in a little container here. There's a couple of switches missing, I guess they are inside. There we go, there's one switch missing. And we'll pop all of these parts away for a moment. Okay. Capacitors look intact, but I think our D882 transistor, as we said, has burned. Yep, you can see that. See that there? In fact, that part has burned, and so clearly is faulty. Otherwise, the printed circuit assembly looks very much like a conventional Astro Wars. This is an early version of the game. The way you can tell this is an early version, at least the way I've discovered to tell if there's an early version, there's a part tucked away in here. I think it's a Zener diode, I don't know it is, certainly a diode. It's called SO6. If you have an SO6 in an Astro Wars but you don't have right next to it SO11, then that's an early version board, and I suspect that failures of SO6 can, well I know in fact that failures of SO6 can lead to the game going quiet and also to failure and overheating of this part. Now unfortunately what I don't know is what that part SO6 is, because there are no markings on any of the ones that I have seen. I'll take a careful look at this one, but my guess is that it's not going to be marked. But the first thing to do is we'll get this D882 replaced. I think the one I have is in a slightly different package, but that's fine. We'll get it hooked up to a current limited supply so that we're not running it straight away at the maximum current that you would deliver from batteries. And we'll see if it starts to get warm. If it does start to get warm, we'll look for problems elsewhere on the board. If you can see that, and I can get a close-up of that part, if it will focus, you can see on it there are burn marks on the part there. So clearly that is the problem. Alright, so we've got two transistors, our failed one, our hopefully new and working one. In fact, it is in the identical package, it's identical in every way. The legs haven't been trimmed, so I was mistaken, just memory didn't serve. I don't know why I've replaced so many of these now. And then slide in our part. Like so. It can just stand up. I don't think it needs to lay down. All right. Solder joints look good. I think we got that in the correct orientation, hopefully. Yes, I believe we did. So we'll get those leads snipped and then we will try the game. So I'll just zoom out, show you my handsome legs for a moment, just so you can see what we have going on here. We have our power supply, a bench power supply. It's a pretty cheap one, I think, from Amazon. Set, I don't know if you can see that, it was set to about 6 volts. It is set to about 6 volts, but currently it's current limited. So you don't see that on the display, but it's set to 6 volts. And then I have it hooked up to our Astro Wars here. And what I've done is, that's normally the switch, that's normally the power switch, so I've just bypassed that. So I've put the power on straight to the circuit side of the contact switch there, and then we're going just through the ground on the connector that we'd ordinarily go in with the power supply. So what I'm going to do now is I'm going to slowly increase the current from my bench power supply, and I'm going to keep my hand on here just to see if this transistor gets hot. Now in normal use it shouldn't, so let's see if it does. So I just moved off camera so you get a better view of what's going on, so I'm going to increase this current now. Currently about half an amp. That seems like a lot. And at 1 amp we still have no life. And that's starting to get hot, so we're going to ram that right back down. This is clearly at fault. It clearly was at fault because it was broken, but it's not all of our problem. So I'm now going to turn my attention to this diode that's tucked to the back here, and that's just because they've experienced that experience gained through my earlier repair. SO6 is hard to get to. It's kind of buried away behind the display, and the problem is, of course, is that you don't want to bend the display here because you don't want to crack this glass and break the vacuum. So it is quite difficult to get in there. I think what I'm going to do is I'm going to disconnect the rest of the electronics so I can just have a little better access. So the noise you hear in the background is my desoldering station. I'm going to sneak in here and see if I can show you that SO6 part. I don't know if you can see it. It's right down underneath the bottom of this display. Like I say, I don't want to spend too long kind of moving this back. I want to try and work around it because I don't want to bend this and damage the display. But SO6 is tucked away right in there. And on a more modern board, as I say, you'll see an SO11 in parallel with it, sorry, in series with it. I'm going to try and take that out and see if I can find out what that part is. Now, for a long time I've had a theory that in fact it is a 140 volt Zener diode, but I cannot prove that. Interestingly, this SO6 seems to have very long legs on it. Like maybe it's been replaced before, but I don't see any rework on it, so maybe it hasn't. Either way, let's sneak it out. So here it is, and we'll take a good look at it to see if it has any markings on it. And it does not. And it's like, you know, I see these little diodes with a red stripe on, but I've no way of identifying it. Now I did try and buy a 140 volt Zener, but it doesn't look anything like this, so I'm kind of dubious about trying those, but maybe we will. I have some other Zener diodes, so let's take a look at those too. I have values, looks like are going up to about 37 volts, and I think that this is 140, so I bought 140 volt one. It doesn't look anything like it, it's much bigger than the one that came out of the game, but I'm going to try it. And if it works, I'll give you the part number. Let's stick this in the tester and see what it looks like to the tester. Well, it sees it as a diode. So let's pop it in circuit and see what happens. So after some impatient fiddling around, I failed to get this in, so I've decided that in fact it's not lazy, it makes perfect sense just to try and solder this temporarily in from the rear of the board here. And then if it does work, we'll solder it in more permanently. Let's try again. Brilliant. That is fabulous. If you can see that or not. There we go. And that seems to be working fine. It's drawing 0.2 of an amp according to my power supply here. And our D882 is a little warm, but certainly not hot like it was before. Display is good and bright, nice and clear. I think we have a working Astro Wars. So now I'm going to try and solder that diode in properly, and then we're going to leave this to play for a little while and see if it continues to work. So I'm just trying to get the leg spacing correct on this side of the board before I try and fold it, put it in from the other side. So I don't know if you can see that, I did manage to get that part in there. It was a bit fiddly to get in place. It is larger than the part that came out, so obviously it's not a like-for-like replacement, but it seems to be doing the job. We see the pins there on the back, we'll go ahead and get that. So here are loose wires, we'll go ahead and get those soldered in now. I did have to bend the display slightly to get it in situ, but I don't think I caused any damage to that. Let's put this into soak testing and see if it will run for an extended period of time. So I left the Astro Wars running for several hours and I didn't run into any difficulties, so I'm pretty sure that the problem is resolved. Now I do need to talk a little bit about the part that I used to effect the repair. I used a 140 volt Zener diode to replace SO6. Now SO6 might not have been a Zener diode at all, it could have been a normal diode which had a reverse breakdown voltage of around 140 volts, or it could have been another value in the 130 to 150 volt range that would have worked just as well. As I've said many times, I'm not an expert in these repairs, so please don't troll me too heavily if you disagree with the conclusions that I drew. But I'd really like to learn about other people's experiences repairing these games and the parts that they have used successfully to replace SO6. The part I used was a 1N5275B Zener diode. I bought my parts on eBay, but unfortunately at the time of posting this video onto YouTube, I don't see them available from UK sellers, although they are available from international sellers for shipment to the UK. And I'm sure there are alternative parts available that would work just as well. Looking online, the part does seem to be available from many electronics distributors in the US and some in Europe. But if you repair an Astro Wars and have success with an alternative part, then I'm sure we'd like to hear about it. So I'd grown quite fond of our Japanese Astro Wars, but I decided that the money I had tied up in it would be better used ploughed back into the channel to buy new items for repair. So having paid £50 for it in non-working condition, I put it back on eBay with a starting bid of around that, and I waited. And it received one bid of £49. Now of course after shipping costs, eBay fees and PayPal fees, I made a fairly significant loss. I saw the game on eBay shortly after, described as in near mint condition and with a selling price in excess of £200. So I guess you just can't win them all. But I don't do this for the money, I do it for the entertainment, and I do hope that you have been entertained by the video today, and that if you have, you might consider hitting subscribe. In the meantime, I would genuinely like to thank you so much for watching Retro Tech Repair.